It's like I don't care about nothing, man. Yeah. Oh,
Okay, so this video is going to be similar to the one before, where we're using our angle relationships to go ahead and fill in proofs. The main difference is these ones are going to be slightly tougher in that we now are dealing with multiple transversals. So most of them are going to have two different types of transversals. Some of them will have three, but the way you go about solving them is pretty similar. So the first problem in this video is going to be number 7 on page 16. We are given that 4 and 7 are supplementary and 8 and 16 are congruent. We're trying to prove that line 1 is parallel to line 2 and T1 is parallel to T2. So the first two should be freebies. There's no reason you should miss this. The beginning of a proof is always the givens. So the statements are going to have to be what's given to us, the reason it's given. I am not opposed to having a shame bell if you get problems like this wrong, because you should always know a proof starts with a given. So the first given to us was that angle 4 and angle 7 are supplementary. That is the first thing given to us. Now, the other thing that was given to us is that angle 8 is congruent to angle 16. So 4 and 7 add up to 180 because they're supplementary, and 8 and 16 are supposed to be congruent. The next one says angle 7 is congruent to angle 6, so 7 and 6 are supposed to be equal, and 13 and 16 are supposed to be equal. If you notice, the two sets of angles they gave us are directly across from each other, so that would be called vertical angles. So our answer for this one would be vertical angles. Now, the next one says substitution. Substitution is meaning that things are going to be equal, but they're different with each other. So what I'm going to go ahead and do is just use the same ones that they said here. So I'm going to say angle 7 is equal to angle 6, and angle 13 is equal to angle 16. No point in reinventing the wheel. They already talked about ones that could potentially be substitution, because substitution is saying that they're the same, but they're technically different because they're in different spots. So they would be the same value.
We are same, but different, but still same.
So this stuff here is what we're trying to prove. So we have to figure out why the lines are parallel in here. Now, if you remember from page 3, that's what I was going over, where the ones down low on page 3, where you're dealing with the different types of angle relationships like alternate interior, corresponding, consecutive interior or exterior, those ones would show that they're parallel. So we have to figure out if we have anything like that in here. So if I'm looking at line 1 and line 2, I'm looking at these two. So I am completely ignoring this right side over here. I'm only focusing on what's over here. And the only things I talked about on this side was 4, 7, and angle 6. Now, we were told that 4 and 7 are supposed to be supplementary, but we also said 7 and 6 are congruent. So I do have an angle relationship for 4 and 6, and the angle relationship, they're both inside of the parallel lines, and they are both on the right side. So we are going to say consecutive interior angles. again, consecutive interior angles have to be on the same side of the transversal, and they also would have to be inside the parallel lines to be interior. The next one, the last one, is why is T1 and T2 congruent? Well, for this one, we had said that angle 8 and angle 16 are congruent. That was actually one of our givens. Now, this is an angle relationship that we should know, and so they're both on the left side of the transversal, and they also are both underneath the parallel lines. So this would be called corresponding angles. So that is how you would fill in this one here. So for the proof that I'm looking at now on page 17, number 10, this one wants us to complete the proof by circling the correct highlighted words. So we get to choose between the highlighted words that we have here. Now, we are given that angle 1 is congruent to angle 3, so these two are equal. And the line segment AC is parallel to the line segment BD. They're wanting us to prove that AB is parallel to CD. So something I like to do when I have something like this is to make it look like something we're more used to is continue the lines. So they told me AC were parallel lines, so I'm going to continue them out so they look like the line, like parallel lines that we're used to. And we're also trying to prove that AB and CD are congruent, so I'm going to continue these ones out as well. So now it looks a lot more similar to the problem before, where you had the two sets of parallel lines and the different transversals. So we're going to go through and see what we can figure out. So they said we're given that AC is parallel to BD. We can say that 2 is congruent to 3 so we want to look at 2 and 3. 2 and 3 are here. So what I'm going to do is pretend like this part up here does not even exist. So if I'm looking at 2 and 3, these would be my parallel lines. And you notice that they're both underneath the parallel lines on this right side. Now that would be our corresponding angles. So they are both on the same side of the transversal, and they are both underneath their respective parallel line. So it can't be alternate exterior because they're one of them's inside, the other one's out, and they're both on the same side. And it can't be consecutive interior because 3 is not on the inside of the parallel line. So we chose corresponding. So corresponding angles are congruent if the lines are parallel. Since it was given that 1 is congruent to 3, and now 2 is congruent to 3, we can conclude that 1 is congruent to 2. So which one do we want to choose? Well, I'm going to look at how many numbers we're saying are congruent. So we have 1 to 3, 2 to 3, and 1 to 2. So if you notice, you have 3 different angles that we're dealing with. So reflexive deals with one when it has one thing being said that they're equal to each other. Symmetric is when 2 different things are said to be equal. And transitive is 3 or more. So in this case, since they talked about 3 or more being congruent, I would want to choose transitive property. And next they say since 1 is congruent to 2 and they are So we have to now choose which type of angles they are. So if I'm looking at 1 and 2, I am pretending like this side does not exist anymore. So if you need to cover it up just like I do, go ahead and do that. Now if you notice, 1 and 2 are both inside of these parallel lines, but they are on opposite sides of the transversal. When you see that, they are on alternate sides and on the inside. So I am going to choose alternate exterior angles. So by doing that, we can prove that AB is congruent to CD by the converse of alternate interior angles theorem. So we have now chosen all the correct answers. So next we are looking at number 13 on the next page. It says we are given that P1 is parallel to P2, P2 is parallel to P3, L2 is perpendicular to P1, and L1 is perpendicular to P3. Prove that line 1 is parallel to line 2. And we go on to say it is because it is given that P1 is parallel to P2 and P2 is parallel to P3, then P1 is parallel to P3 by the, so we have 3 different things being said that they are parallel. So I am going to use transitive property. So transitive property deals with 3 or more things being congruent, they're equal, or in this case parallel. So that is the first blank. So this means that angle 1 is congruent to blank because they are corresponding angles. So basically the idea is as if I do not have this line in the middle. So if I was looking at P1, P3, they would both be on the right side and above their respective parallel line. So I would be saying it would be corresponding with angle 2. So the next thing says if L2 is perpendicular to P1, so perpendicular tells us it has to make a 90-degree angle. So L2 with P1, and they put the box here to show that it was 90 degrees. Then angle 1 is 90 as well. Thus angle 2, since they were corresponding and congruent, would also have to be 90 degrees. This means P3 is perpendicular to L2 based on the definition of perpendicular lines. It is given that L1 is perpendicular to P3, so L1 is parallel to L2 based on the corollary that states, this goes back to page 3. It's one that we haven't talked a whole lot about, but this would be the perpendicular transversal theorem. Perpendicular transversal theorem. So in that theorem they say if the angles are perpendicular 90 degrees, all of them have to be 90, which would be dealing with parallel lines as well. Okay, so we only have one more problem left for this video. We are told that we are given that A is parallel to B, C is parallel to D. We're trying to prove that angle 1 is congruent to angle 11. So I know I'm going to need to make sure that since that's what I'm trying to prove, that I use those numbers somewhere in here. But to begin, again, you should never, never, never miss these first 2 because we were given 2 things, so we're going to write what we were given. So A is parallel to B, and C is parallel to D. If you get those wrong, your outlook is bleak. So make sure you're getting those correct. These should be the freebies. So now let's continue on. They told us that angle 1 is congruent to angle 3. So 1 and 3 are congruent. They are directly across from each other, so that would be our vertical angles. So those are vertical. They also go on to say 3 is congruent with 7. So 3 goes with 7. They are both on the left side of this transversal, and they're both underneath this their respective parallel lines. So this would be corresponding angles. So that would be for what 3 and 7, that angle relationship. Now we say, they also tell us that 1 is congruent to 7. So they are both outside of the parallel lines, and they're on alternate sides of the transversal. So this one, we would want to say alternate exterior angles. So for number 6, it says if two parallel lines are cut by a transversal, then corresponding angles are congruent. So we're going to want to choose corresponding angles, but we want to be careful with which one we choose. If you notice, we've already used 1 multiple times, but we have yet to use 11. So we want to use a corresponding angle that uses 11, and preferably one of the numbers that we used already. So if I look at where 11 is, it's on this side, and it's above this parallel line, so I would want to use 7 to go along with it. So 11 would go with 7. So this one must be open 24/7 because we are dealing with 7, 11. See what I did there? 7, 11? Yeah.
Right.
Now the last thing is what we're trying to prove. So we're trying to prove that angle 1 is congruent to angle 11. So there's multiple answers I would have accepted. So I would accept that 1 is congruent to 11 based on, you notice that we said more than 3 different angles were congruent to each other. So I would accept transitive property. I would also have accepted substitution. So those would be the main ones that I would accept. There probably are a few more that I would have accepted, but these are the main answers I would have been looking for. So that's the end of this video. Hopefully you found it informative. For practice, I want you to do page 16, number 8, page 17, number 9 and 11, and page 19, number 16. So those will help you prepare for what you would see on the test.